Hello, next we have graphing a logarithmic function. Now remember we said that log function is defined as the inverse of the corresponding exponential function. That is the basic definition of log function. And if you remember from the last 4.1 section, we said that for any function, say we have f of x, the inverse function's graph would be mirror image in the line y is equal to x. So this line, the diagonal line, is the line y is equal to x. So the graph of f of x and f inverse x, they are mirror images of each other. So if we already know that this blue curve is the graph of b raised to power x if b is more than 1, that means the graph of log of x with base b, where b is more than 1, would be this red curve increasing from left to right. But in this case, it is all its domain. What do you observe? That the domain x values is from 0 to infinity, and the range is going from negative infinity to infinity. On the other hand, if the graph is b raised to power x, then the curve is blue curve and its mirror image in y is equal to x line would be this curve, red curve. So the graph of log function, if the base is less than 1, is a decreasing function. The log function with base less than 1 is a decreasing function whose domain still is from 0 to infinity and the range is negative infinity to infinity. From the domain, what you need to remember is that important point here, log function is not defined for negative numbers. Negative numbers. This is very important fact that any log function cannot be found for a negative number. Now let's see if we want to graph this function y is equal to log of x with the base 2. How will we graph this function? You can use the calculator. In calculator, you need to, for any graphing, you need to click y equal to. Now this is log function. So if you simply write this expression here, that would be just giving you common log. You do not want common log. You want log with base 2. So you need to press math. If you go down in the list, you will find at A, it's a log base. So you need to select that. That gives you this log function with the base slot. So you can write 2 here and x here. That is what it's asking, log of x with base 2. So the graph of this function, we knew that the base is more than 1. That means the graph of this function is going increasing from left to right. X-intercept is always at 0, 1. Sorry, 1, 0. The x-intercept of log function is always at 1, 0. Why? Because log of 1 with any base is always equal to 0. So log of 1 with base 2 will also be equal to 0. So x-intercept is always 1. This is your log function's graph when the base is 2. Similarly, let's try to find the part log of x with the base 1/4. Then what happens to the graph? So go on y. I'm going to just change in this. In place of 2, I'm going to write 1/4. Now it is log of x with base of 1/4. Let's graph it. That function is a decreasing function from left to right. As x increases, the function decreases, but this function also passes through the point 1, 0. X-intercept is always 1, 0. Domain is still 0 to infinity, and the range is negative infinity to infinity. So here are the graph of these two functions. The first one is the graph of log of x with base 2. It's an increasing function. It passes through the point 1, 0. Then next is we have log of x with base 1/4. It is a decreasing function. Domain is still 0 to infinity in both the cases. Both the functions pass through the point 1, 0. Both of the functions have the range negative infinity to infinity. So to conclude all this, I have made this table for all this information for you. For the graph of log function with the base b, if base b is more than 1, it's an increasing function. If base b is less than 1, it is a decreasing function. Domain for both of these functions will be 0 to infinity. That means log function is not defined for negative numbers. It's only defined for positive numbers. It's also not defined for 0. The range of the log function can be anywhere from negative infinity to infinity. Both log function does not matter the base. They always pass through the point 1, 0 on x-axis. This point is 1, 0. Vertical asymptote. Y-axis is the vertical asymptote for this graph. Now in base, if base is more than 1, smaller the base, faster the graph climbs towards right. So you see here, the red curve is the log of base 2. The black curve is log of base 3. So smaller the base, it is climbing faster. It is reversing as in the exponential function. Similarly, on the other hand, when base is less than 1, larger the base, faster graph falls towards right. Falls meaning decrease towards right. Okay. So using all this information, let's figure out how to find domain of some of the log functions. So example number 7 asks us, identify domain of the logarithmic function. Write the domain in the interval notation. The first function is log of 2x plus 4, the base is 2. Now what you need to remember, log is defined for only non-zero positive numbers. This is the important fact. That means for this log function to be defined, 2x plus 4, the number whose log we are taking should be strictly more than 0. That means it cannot be equal to 0, it cannot be less than 0. So we can solve this by subtracting 4 on both sides. We would get 2x is more than negative 4. By dividing both sides, we would get x is greater than negative 2. So my domain would be equal to negative 2 to infinity. Remember, do not put a close parenthesis because at close parenthesis this becomes 0. We do not want this whole expression to be 0 because log is not defined at 0. So this is your domain of this function. You can check it out using the graph in the calculator. Let's clear it. So we have math at down log base function. The base was 2 and the function is 2x plus 4. Let's graph it. So as you notice here, it does not go before negative 2. The asymptote is at negative 2, right? So the graph domain is towards x is more than negative 2. Let's try part B. G of x is natural log of 5 minus x. It doesn't matter it's common log, it's natural log, or it's log base any other number. Log is not defined for negative numbers. That means 5 minus x has to be positive. 5 minus x will be positive if x is less than 5. That means domain of g of x will be equal to negative infinity to 5. Next we have h of x is equal to log of x square minus 9. So that means x square minus 9 should be strictly positive. X square minus 9 is x minus 3 times x plus 3. Should be strictly positive. So on number line, I have 3 somewhere and I have negative 3. If I pick point less than negative 3, this number would be negative. This number would be negative 2. So this function is positive here. Why? because negative times negative is positive. If I pick something in between, let's say 0, at 0, the function's value is 0 minus 3 is negative, 0 plus 3. So that will be negative. And if I pick something more than 3, let's say 4, both of them are positive, so the function is positive. We want x squared minus 9 to be positive. Where is x squared minus 9 positive? In this area and in this area. Okay. So domain of the function would be negative infinity to negative 3 union 3 to infinity. Let's read this last application problem. The intensity I of earthquake is measured by a seismograph, a device that measures amplitude of shock waves. I naught is the minimum reference intensity of zero level earthquake against which the intensities of other earthquakes may be compared. The magnitude of an earthquake is given as m is equal to log of common log of I by I naught. What's the question? Determine the magnitude of earthquake that devastated Haiti on January 12, 2010 if the intensity was approximately 10 raised to power 7 times I naught. So I is given to be 10 raised to power 7 times I naught. The question is to find the magnitude of the earthquake. Magnitude is defined as log of I divided by I naught. I is given to be 10 raised to power 7 times I naught divided by I naught. I think I naught can be cancelled. So that is basically log of 10 raised to power 7. Log, it's common log. So the base is 10. This is 10 exponent. That means the answer would be just 7. So the magnitude of the earthquake in Haiti was 7. Let's try part B. Determine the magnitude of earthquake that occurred near Washington, D.C. on August 23rd, 2011 if the intensity was approximately 10 raised to power 5.8 times I naught. So I here is given to be 10 raised to power 5.8 times I naught. So m would be log of I divided by I naught, log of 10 raised to power 5.8 times I naught divided by I naught. We have, this will be cancelled. So we have log of 10 raised to power 5.8. This is common log. So log base 10 and 10 would cancel and we will be left with 5.8. How many times more intense was earthquake that hit Haiti than the earthquake that hit DC? So intensity of Haiti's, that is, let's name this actually I1 and I2. How many times more intense the earthquake that hit Haiti was than the earthquake that hit Washington, D.C.? So we have to divide I1 by I2. That means 10 raised to the power 7 I naught divided by 10 raised to the power 5.8 I naught. 10 raised to the power 7 divided by 10 raised to the power 5.8. We can use calculator. This is 15.84. So 15.8 times more intense than the Washington DC earthquake. That finishes our chapter. Let's do concept connections quickly. Given the positive numbers x and b is non equal to 1, y is equal to log of this, x with base b is the log function, logarithmic function with base b and is equivalent to v raised to y equal to x. Given y is equal to log of x with base b, y is called exponent, b is called base, and x is called argument. Log base 10 is called common log. log base e is called natural